Hi, it's Mr. S, and today I would like to talk about area of special quadrilaterals and triangles. So the goal for today's video is to understand the concept of the area, and understand the background of area formulas for those figures that I will do. So let's look at area. You've probably have experience. It's talking about how much space can be there inside a figure. Like if you're given this square right here, how much space are inside this? How much do you have to fill in? How much space do you have to use to fill in, that kind of thing. And the unit is something squared, like unit squared, centimeter squared, feet squared, inch squared, something like that. And it represents how many 1 by 1 squares fit into a figure. For example, like if you have the answer like 40 centimeters squared, that means in that figure you can put 40 of this 1 centimeter by 1 centimeter squares. 40 of these. That's just an example, but this is the concept of area. Now in schools you might be asked to calculate the area, like say find the area of a rectangle, find the area of a trapezoid, area of a circle, things like that. But today I would like to do give you the formula. It's there already, and I'll like to talk about how these formula are related to specific figure, which will be rectangles today. And these are the topics. I'm going to do 5 of these. Right, let's take a look one at a time. Rectangles and squares. Its formula is length times width. Length times the width. In a square, it'll be side times side because all 4 sides are equal length. Now, if you're looking for area of a rectangle, that means you're multiplying length times width, number of length times number of width, and say how many those 1 by 1 squares fit into this rectangle. That's easy. Now let's look at something that's different from rectangles, say parallelogram. The formula is now base times height. Well, it looks similar, it's something times something, but it uses different words, base and height. Now here's what I would like to do. From this parallelogram, let's make a rectangle. See if we can make this shape from this parallelogram and see how those formulas are related to the formula of a rectangle or square. And the way to do that is you can cut them, paste them, however you want to do. In a classroom, you can actually give students or yourself a paper cut into those parallelogram and say, use this thing and try to create a rectangle from this parallelogram by cutting and pasting and things like that. One way you can do is from here, or it doesn't matter where, but from here or whatever, straight down to this line, to this bottom side, and cut them and move this to here. Move this part that you cut to this part. Now make sure this line meets to the bottom at 90-degree angle. Once you get that, you'll have a rectangle made right here. This blue and dark blue. The length of a rectangle, let's say this part, it might be width, is here. In a parallelogram, that's right here. Or here, doesn't matter which one it is. These two sides are same length. And the width, or the length is this side. The other side is right here. That's here, right here. Not the side right here. It's this vertical line that I just drew. So in a parallelogram, its length times width will be base, which is one of the side, times the height. Reason why I said 90 degree is because I need you to make the height. Like when you're measuring yourself, your height, your height of a human, you don't stand up like leaning like this way, right? Or this. You actually have to stand up straight, like even you have to like stand on the wall, this, so that you can make a 90-degree angle between you and the floor. Right, so that's the parallelogram, where that base and height came from. What about rhombus? The formula looks like this: half times diagonal, 1 and 2. I'm just putting 1 and 2 because just to say these diagonals are different. That's a diagonal, another diagonal. One way you can do this to make a rectangle is by cut in here and then move it to the other side. You can cut this on here horizontally and move this upper to the bottom or bottom to the upper. It doesn't matter which way you want to do. And then you make a rectangle right here. Now in this rectangle, here's the width. That's the same length as here, but that's only half of the diagonal, right? This whole diagonal, but you're only using the half of it. So here's the half diagonal times the width, or the length, sorry, whichever it is. Length and width, let's say width. That's this part, same as here. That's another diagonal, that's a diagonal. It's not half, it's not double, it's just a diagonal. So the area will be half of the diagonal times the diagonal in a rhombus. Also, you can think this way. Make a big rectangle and say, here's the length. Well, that's the same length as this diagonal. Here's the width. That's the same as this diagonal, the vertical diagonal, and say length times width. Diagonal times diagonal. But that'll give you the area of this big rectangle. Big rectangle. But you don't need the whole rectangle, you just need this rhombus inside. You don't need this extra dark blue things right here. As a result, I'm just going to say in conclusion, this rectangle, small rectangle, look at this small rectangle. The triangle is half of this small rectangle. This one small triangle right here is a half of this small rectangle. Same thing for this small rectangle. This triangle is half of this rectangle. Or you can say this triangle has the same area. Same thing with this rectangle, same thing with this rectangle. So each of these triangles isn't half of this small rectangle. Well, that means it's a half of this whole rectangle. So diagonal times diagonal divided by 2 will give you the rhombus area. Here it is. Next one is a trapezoid. It says half times base 1 plus base 2 and then times height. I forgot to put the multiplication right here, but I'm just using this as a sign to represent multiplication. Well, where's that base 1 plus base 2 come from? Here's some, I think is the best way to look at this base 1 plus base 2. Duplicate. Copy and paste by flipping it vertically and say base 1 and base 2. Here's the base, here's another base. Now let's say base 1 plus base 2 length. Or this way, it doesn't matter which way you want to choose, but here's the base, the big base, I guess you call it. Base 1 plus base 2. This shape, it's familiar, right? It's a parallelogram, right? So you can do this again. Move this part, move it here. Now the base 1 plus base 2, here's that. Height is here, which is from here to here, or in this case here to here. Make sure you're making that 90-degree angle. And then where's that half from? You made 2 trapezoids, but you don't need 2, you only need 1. So it's half. So this part will be the length times the width of the rectangle, and then you're making it only 1 by dividing by 2. And the last one is triangles. There are different triangles exist: isosceles, scalene, right triangle, and there are equilateral ones. I'm not going to do that one. It's kind of similar to this isosceles. Here's some of the ways you can think of different ways. You can ask students, if your teacher say, hey, from this triangle make a rectangle, or understand where's that these formulas from. And say you can say, hey, I can make a rhombus from here. We know rhombus, it's going to be a well, in this rhombus, it's make sure you don't forget to divide by 2 after you got the area of a rhombus. You don't need 2 triangles, you just need 1. You can do parallelogram right here by copying this to this side, or you can say cut it in half right here and move it here, make a rectangle, or say make a big rectangle and that's half of it. Either way, the base will be here, height is here. Another way for another triangle, scalene. Now I have these lines right here. It's just representing the height. From this point, the height is here. If you're saying this is the base, if this part will be the base, this will be the height. If this is the base, this will be the height. Ooh, why is it meeting at one point? That's something you might want to think about. Might want to explore this. It's going to be in some higher level geometry, I think, but it's kind of cool. Anyway, so if you put this on the bottom, it's going to make a parallelogram. Not like this part, not a rhombus. This side and this side, they're not equal. So it's not going to make a rhombus. For isosceles, these 2 sides are equal length. That's why it's called isosceles, and it makes a rhombus, all 4 sides equal. But this is not all 4 sides are equal. 2 sides are. So it's a parallelogram. Same thing here, and also making a rectangle. Right triangle, probably easiest way to think about this is get a rectangle, and it's half of it. Right? So different options you can look at for triangles, but it's base times height, and then divide by 2. Half of the rectangle. So I don't have enough time to do this, but here's the NCTM resource. You can look at how dimensions and area are related. I'm not gonna just give you just this video might be a good idea. It gives you a rule investigating how dimensions like base, height, area, all that stuff are related, and also it asks you to generate a formula by looking at a pattern. So thoughts about this, what you can do the way I did it, give out the formula and then understand background, or you can do, and I would probably suggest this one, give the rectangle background, probably students have that already, and then create a rectangle from it and see how the formulas are related, or how those formulas are invented. And there are other figures you can look at, like these, like this quadrilateral. Alright, so that's the end of the video. I hope you enjoyed it. Please like, leave a comment, and subscribe my channel, and I'll see you in the next video. Bye bye.